right, so for lesson 3 of unit 5, we're going to focus on properties of rectangles. So the properties of rectangles include all of the properties for parallelograms, and each interior angle is 90 degrees and the diagonals are congruent. So what does that look like? So that looks like this. With a rectangle, each angle is 90 degrees, and we know that the diagonals, if I can draw them fairly well, oh, that's so sad, oh, gross. The diagonals are all congruent as well. So this length and this length are congruent, and therefore each of these smaller lengths or segments are congruent. Okay, so looking at, let's take a look at a few examples. It says quadrilateral. RSTU is a rectangle with diagonals that intersect at P. If the measure of angle RSU equals 3x minus 5, and the measure of angle UST equals 4x plus 4 degrees, find the value of x. Well, the first thing I would suggest is let's draw this rectangle so we know what we're working with here. So rectangle. And we're going to label this rectangle R, S, T, and U. So R, S, T, U. We have diagonals that intersect. Oh, well, that was just terrible. Let me see if I can erase it and create or draw another one that would be better. All right, we're going to try this again. Okay. So here is a rectangle whose diagonals intersect at P. It says if the angle RSU is 3x minus 5 degrees, and the measure of UST is 4x plus 4, we will have a okay, so let me rephrase that. So we know that the measure of RSU is 3x minus 5 degrees. We also know that the measure of angle UST, this angle, has a measure of 4x plus 4 degrees. And what we want to find is the value of x. We know what the entire angle we know what the measure of the angle is itself. It's 90 degrees because it's a rectangle. But what I want to do is, if I really wanted to know what each of these measured out to be, then I can use my information that's given. So what I know is that 3x minus 5, when I add it to the other angle, 4x plus 4, I know it will equal 90 degrees. So 3x plus 4x is 7x, negative 5 plus 4 is negative 1, equals 90. Add the 1 over, and I get 7x equals 91. And x will go into 7 will go into 91 13 times. So the measure of angle 13, or the measure of x, is 13. All right, so now let's look at another one. It says quadrilateral ABCD is a rectangle. We have another rectangle with diagonals that intersect at point P. We know that AC is 4x minus 13 and DP equals x plus 7. Find the value of x. So I'm going to draw my rectangle again. I will label it A, B, C, and D. I know that I have two diagonals and they intersect. Let me turn this to see if I can draw it decently. And I know that, excuse me, that AC has a length of 4x minus 13. So AC is 4x minus 13. And D, oh, hold on a minute. Oh, here is P. I forgot that this intersects at P. So I know that DP is equal to x plus 7. Okay, well, if DP is x plus 7, what about DB? DB will be 2 of those. So that's 2 times x plus 7. Okay, so why did I need to do that? Well, because since this is a rectangle, I know that the length of this diagonal will equal the length of this diagonal. So I can take AC and set it equal to DB. So the measure of AC is 4x minus 13. The measure of DB is 2 times x plus 7. So I have 4x minus 13. I will distribute and I get 2x plus 14. I will subtract 2x to get 2x. I will add 13 to get 27. This is gross. And dividing by 2, I will get 27 over 2. So all we wanted to do was find the value of x. Okay, so if we wanted to take this out to a decimal, that would be 13.5. So the value of x would be 13.5. Okay, so one final example for rectangles. We have another rectangle, JKLM. This is J, this is K, this is L, this is M. I have diagonals that intersect at P, point P. I know that LP is 3x plus 7, and MK is, all of this is 26. So I could do one of a couple of things. In a rectangle, what am I trying to find? Oh yeah. So in a rectangle, all the segments are congruent. If this whole segment from M to K is 26, then half of that would be 13. So I can take 3x plus 7 and set that equal to 13, and that way I can solve it for x. So 3x, I will subtract 7. We get 3x equals 6, so x equals 2. And there's the value of x.